Hey folks, Federico here. In this third video we are going to not do anything super crazy, it's a relatively short one. What I want to do is to tidy up what we already got from the previous video, and for example renaming the grid folder file to folder tool, which I don't know why I called it grid folder. And then I'm going to show you how we can access the jit.world events, like for example the bang that comes out at each frame, or the mouse position in the window directly from within JavaScript using this, basically, our jitter listener to a jit proxy that is connected to the jit.world. So not difficult, but very, very useful. And we tied a bit up the menu. Here looks a bit nicer. And as you can see, we are getting the mouse position in our console. So if this sounds interesting, remember you can always watch this video ads-free on my Patreon. So this is another benefit that you get by joining my Patreon. Plus you can download the patch and the code and all the patches I ever released for a small fee. So if you're interested in jitter and Max, I'm sure you will find something useful there. But now, without any further ado, let's jump into it and have fun. Okay, so I just reopened the patch as we left it in the previous video. And the first things we're going to do is that we're going to make a couple of improvements on how we left the code last time. So just improving what we already got. So for example, the tiles menu here, I don't like it so big. I would like to make it smaller so we can scale it down a bit. So let's go into jit.ui here and say I also added off screen this set label tiles, which will set the title here, but as you can see it's too big, kind of goes on top of the border, so we have to fix that as well. First thing I want to do though is scale that down, and maybe we want to scale it to 0.5. Let's see how that looks. 0.5 is possibly too small. Let's make 0.7. 0.7, I think it's good. I think this is a good size for our tiles menu. Now, if we click here on the tiles menu, you can see that this anchor, which is a point in the 2D screen that we can set its position, and the menu or any jit.ui object will always maintain the same distance from that point in the screen. And so I want to put this on the left top corner, so the menu will always maintain the same distance from the top left corner. And this is much nicer. So what we're going to do is to make here a new line, set position anchor percentage, I think it's called, and 0, 0 is just the percentage from 0 to 100 on the X and Y axis, with 0 being the top. So that should do it. Let me save and recreate that. I may get here our console, don't see any errors. And as you can see, the anchor is now placed on the top left corner, which is good. Then I want to set the width of the menu to an amount that will make it nice, and the height as well, so that we get a certain amount of columns and rows that we can decide ourselves instead of letting it automatically do it. So we can say, for example, this could be 180 or 179 by 365. This looks good. So we have to say here set width. How much did I say? 180. 180 pixels. And that will be set height 365. Save that. Actually, I think we should take the scale into account, so this pixels value should be before scale. But let's first try and see what we get. And indeed, I think this is before scale, so what we can do is simply divide that by our scale value, which is 0.7. So this should account for the scale. Let's see if this works. And it works. Nice. Now we just need to set a nice position for this menu. Let's put it here on the top left. And this, unfortunately, will only work for the snow tile, all this colorful positioning and sizing that we are doing. But for the moment, it's okay. I just want to show you how you can work with the jit.ui group. So let's put it at 96, 100, 36. As you can see, the position is shown here in the rendering window, in the center handle, on top of the center handle. Would be nice if this will be a bit more legible, like the background will actually be on top of the actual menu, which is something I will definitely fix. So 136, 96. So let's go here and say set position 96, 136. Nice. Let's delete, recreate. Still not working. Maybe it was not 136. Maybe it is 185. Oh, it's 86, I think. It's not 36. Yeah, as I said, the position label should be much more legible somehow. It's transparent background, not really good. Okay, but we got our menu nicely placed in our scene. Okay, great. So now another improvement we want to do is to rename this grid folder file. I don't know why I called it grid folder. It's nothing to do with the grid. This should just be actually our improved folder or something like that. This is our folder tool or something. Let's maybe just call it folder tool. So here I want to call it folder tool, the class. And let's see where we use this grid folder in our code. Oh, we can rename that. So here, every time we use grid folder, it should actually be called folder tool. And I think this was it. This we don't need to care about. So actually in our main file here, I want to set auto watch to 0. I don't want that it compiles the JavaScript every time I save here the main file. Okay, cool. So grid folder has been renamed in folder tool. Nice. Now I want to show you how we can get our jit world inside our JavaScript. And this will allow us to have access to the bang of the jit world, the bang for each frame, to the mouse position, mouse click, a bunch of useful informations, a bunch of events that the jit world triggers each frame or when something happens. So this is something that is super useful to know when you're working with jitter in JavaScript. So what we want to do is to create a new file here, grid game. And we can call it just context or something, .js. And inside our main file here, I want to include that. So I will include it right after ff utilities. So or actually after jit.ui, and this is called grid game context.js. Okay, so let's go in our new file. And it doesn't really need to be a class, because this will only contain the context, the callback for the jit world, and a bunch of global variable that we will use to attach ourselves to the world. So maybe we will just use it as a module, as we did in the first video, which then we didn't do anymore, but I think this would be the right approach for that. So we need a bunch of variables. The first one is going to be a jitter proxy, and this is the jitter proxy object, so jit proxy, which it's an object that you can attach to any other jitter object, and you will be able to retrieve attributes from that object. So for example, I can attach it to this grid shape, and then I can say get color. That's not the actual color. I can change its color here, and then I can get the color with this from the jit proxy by sending the get color message, like I will send it to the actual grid shape. So that's a great way to connect ourselves to an object in the actual patcher from within JavaScript. So this is a new jitter object, jit.proxy. Then we need to give it a name. So jit proxy.name. So this is the name of the object to which you will bind. And we will want to connect it to the grid game world, which is our jitter world here. So now this is a proxy to the jit world. And then we need to create a listener. So jit listener for our context. So this is going to be a new jitter listener. And the listener object is going to be jit proxy.send message. get draw to. So we are not sending the listener to the actual JIT world, but we are sending the listener to the GL node inside JIT world, because this is really what will give us all the events from the JIT world. So if you check the JIT world as a draw to attribute, and that's the name of the actual GL node inside JIT world, and that's what we want to bind our proxy to. We did that. The first argument is the name of the object to bind, and the second argument is our callback. So we don't have a callback yet, so let's create it. It's just going to be a constant. It's a function, but we are assigning to a variable. We could actually just write it directly inside here, but just for clarity reasons, let's make it its own variable. So let's call it context callback. And that's a function with an event. This is the event that is passed by the listener object. And then we can like print, for example, ffutils.print the event name. For example, this will show us what event is being currently generated by the JIT world or by its node. So let's go here, and the second argument, as we say, is the callback, so context callback. Nice. So the last thing we need to do here is to destroy all the jitter object that we used here, because they occupy some memory. So the proxy we don't really need to destroy because it's not really an object, it's just like a pointer to another object. So what we want to destroy is the jitter listener. So what we want to do is to create a new function, let's call it destroy. And we want to say jit listener.free peer, right? So we can free its memory. And then we want to export basically just the destroy function, I think, from this as a module. So module.exports equal new object with that has the destroy function in it. And I guess that's it. So let's go in our main file. Let's first delete that. Let's go here and say, at the top, context, how can we call it? It's basically our context listener. It's equal require, and the name of our file, which is grid game underscore context.js. And I think then in notify deleted, we can just say context listener.destroy. This should work, not sure at all, though. Let me recreate that. And so module is not defined. Although it did work because it's giving us the event name, which is WAP. And you know what? Why did I actually include this file? This we are just requiring it. So sorry, I didn't have to include it. I don't know why. I did that, still a bit confused, I guess, with this module stuff. Yeah, we don't need to include this. This is we're using the require keyword to use this as a module. So nice. As you can see, we're getting at every frame. At each frame, we're getting this WAP event. And I've added a little timestamp to the print function. You will find this in some future Max versions. Yeah, swap event, and then when we go with the mouse on the window, we can see the mouse idle, and then if we click, we have the mouse event. So that's pretty cool. So let's say, for example, we want to go here, and instead of just printing each event, let's create a switch statement, and let's switch the event.event name. So we will create different cases for different event names. So for example, in case this is WAP, we will do something at each frame, for example. In case this is the event mouse, then we will do something with the mouse. For example, what I want to do is to print the mouse position. So what we can do is to use event args. And these are all the event arguments relative to the mouse. So let's see what we get. Recreate the game thing, the whole thing. And let's see if I click here with the mouse, you can see that I get the mouse position plus a bunch of flags, which for the moment we will not use, but they will give us informations about, for example, if you're pressing Shift, or if you're pressing Command, or if you're pressing the Option. Okay, so that's very cool in case we want to build like complex mouse interaction with our world, which is probably what we're going to do in this series. But anyway, now you can see that we get the mouse position in the world. And that's actually fantastic because in our specific case, it will allow us to select the, for example, the floor or the models or these sort of things by knowing the position of the mouse in the screen. And the way we are going to achieve for example, clicking on a single tile on our grid and highlighting it, it's going to be done with the jitter physics object. But we're going to do this in the next video. I want to keep this relatively short. In this one, I just wanted to tidy up a bit what we already got with the menu here. And then we created this context catcher thing, which allows us to get access to the mouse position, for example, the bang from the jit.world. And this is especially useful when you're creating your own external, for example, a device that you want the users just to be able to instantiate inside their patch. That's basically how, for example, the GGL mesh works, right? This uses exactly the same system to grab the mouse position, the renderings, and so on. And that's also how other objects work. And so in this way, you can build your own externals that have access directly to the jit.world without the users having to connect something to your object. Okay, so I hope this was useful. As always, thanks a lot for watching. I hope you like how the series is proceeding. In any case, I would really appreciate if you leave me a comment, let me know what you think. Like and subscribe would be much appreciated, of course, and a visit to my Patreon will bring you to download this patcher, the code, and all the other patches I shared during the years. So for a small fee, you can get a lot of content. And okay, so I will see you in the next video. Take care, have fun, and see you soon. Ciao.